Hey, welcome back to your favorite technical mathematics class. We're going to look at problem solving strategies and word problems. So let's take a look at the general procedure. This is what I like to think about when I solve word problems. So I guess. So I find my givens. All right. Then I notate what are your givens, what are your unknowns, name them, let x be whatever, y be whatever. What are your equations that are given? So, or create an equation from the problem, just depending, and then you can just typically substitute and solve the equation. So that's just kind of a general strategy, if you will, for word problems. So here's an example here. States High School Athletic Association separates its schools into two divisions. Together, Division 1 and Division 2 have a total of 332 schools. There are about 5.5 times as many schools in Division 1 than in Division 2. How many schools are in each division? So, number one, what's the givens? Well, given is that there's a total of 332 schools and 5.5 times as many in D1 than in D2. So, and our unknowns are the number of schools. So we're going to start with, besides the fact that we have these givens here, right? Let's start with our unknown. So let's let x be the number, this is x, schools in Division 1, and let's let y be the number of schools in Division 2. Okay. And then it was given, so that's our unknowns, it was given that there's a total of 332, so the number in x plus the number of y is going to give you 332. All right, so there's one of our equations. And they also say, hey, there's 5.5 times as many schools in Division 1 than Division 2. So 5.5 times the smaller amount, y is going to be the smaller amount, will give you the number that are in Division 1. Be careful with that because it's really easy to mess that up. A lot of students will do 5.5 times the x equals the y, but no, it's 5.5 times the number of schools in Division 2, the y, because there's lesser. That gives you equal to the Division 1 x. So we have our unknowns, we have our givens there, we made some equations. Now anytime you have two variables, and we have a variable x and a variable y, you better have two equations there or it's not solvable, which we do. Now we're going to substitute and solve. So we make sure that one of our variables solve for, notice that x is all by itself, x equals 5.5y. So this is equal to y, x right here, 5.5y is equal to x. So we're going to substitute it in to the other equation. So this equation, x plus y equals 332, after the substitution, since 5.5y is equal to x, we can plug it in for x right there. This becomes 5.5y plus y equals 332. So 6.5y, once we add those two up, equals 332. And then we take 332 divided by 6.5, and we get 51. Approximately 51, by the way. 51.077. We got to round it, as it says, round to the nearest whole numbers. So 51, so that's the number of schools in Division 1. And then since we know there's a total, we know that there's 51 in Division 1, and we know they total up to 332. So x plus 51 equals 332. Subtract 51 from both sides, and you end up with, that'd be 281. 281. So there's 281 Division 1 schools, 51 Division 2 schools. Here's another one. 2 low-flying missiles are launched from the same location at sea level, sent in opposite directions. So we've got these missiles, opposite directions. Okay, we got one that's after 5 seconds, it looks like they're 33,000 feet apart. That's just after 5 seconds. They're 33,000 feet apart, it looks like. So one of these missiles is traveling 600 feet per second faster than the other one. So let's call this slow one's distance. We've only covered distance 1 here. And this one's going to cover more distance in 5 seconds, right? That's the faster one. D1 is the slower one. And so if this is going some rate, they're saying, well, however, this is our slow one. And then the other one, 600 feet per second faster. So that's like that plus 600. You know, if this rate, for example, is 100 miles per hour or 100 feet per second, then this one over here would be 700 feet per second because it's 600 feet per second faster. Okay, so that's saying, well, what's the speed of the faster missile? So when you're coming up with the equation for this, I hope when you hear there's a classic formula, distance equals rate times time. So what we're going to use that distance. Whatever the distance covered is how fast it goes times the time. Distance equals rate times time. We're going to do that for both the slow and for the fast one. We're going to use that equation, distance equals rate times time. I like to call that the DIRT equation. Distance is rate times time. Well, this slow one only covered D1 amount. We called it the slow amount, right? The slow only covered this distance here, distance 1, lesser amount, at a slow speed R, but it did do this, you know, R is your feet per second. It did do this in 5 seconds, okay? This other one covered more ground. We called that distance 2 at a faster rate. Remember, this is that slow rate plus 600, R plus 600, and it did that in 5 seconds for T, in 5 seconds as well. Okay. Now notice we have D1 equals 5 times R, we got D2 equals R plus 600 times 5. So we actually have 3 variables here. D1 is different than D2, and then we also got this R. So 3 variables, but we only have these 2 equations. So we need a third equation, which we have a third equation. If you think about after 5 seconds, you know, after 5 seconds we went from here to here, right? 33,000 feet. Those 2 missiles are apart from each other. So that's the distance 1 plus the distance 2. Those are a total of 33,000 feet apart. And now we can make some substitutions. So D1 is 5R. So I'm going to replace D1 right here with 5R. And over here, D2, once I distribute this, is 5R plus 3,000. So I'm going to replace D2 over here with 5R plus 3,000. And this is equal to 33,000. I can solve for R. Subtract 3,000, subtract 3,000. 10R equals 30,000. Divide by 10, divide by 10. So our R is 3,000. This is our rate, right? We're in feet per second here. Well, what is R? If you remember, R was the slow rate. So that's how fast the slow one's going. And remember, what's the speed of the faster missile? That's what we want to know. Well, the faster one was 600 feet per second faster. So since the slow one's 3,000, fast one's 600 feet per second faster, this ends up being 3,600 feet per second. Okay. All right, so let's do next one here. We've got pharmacist wishes to make a solution that is 2% minoxidil. She has on hand 100 meters of a 1% solution, right? So you get this solution and wishes to add some 4% solution, right? To make sure that this is 2%. So she's throwing in 100 milliliters of this 1%, and then we don't know how much, so X milliliters of this more potent 4% to make sure that overall it's a 2% solution. Okay, so the question is how much of the more potent 4% we're going to throw in here. So she's got 1% of this 100 milliliter solution. She's going to add in the very potent or more potent 4%. We just don't know how much. This is how much of the 4% she's going to put in, right? X amount, X milliliters. Because she's got to end up with a 2%. well, how much 2%? How many milliliters does she have? She's already put in 100 milliliters. She's going to throw in X amount more. So it's 100 plus X on this, total milliliters. That's how much total 2% she has. All right, so she has 1%, 100 milliliter of 100, she throws in 1%, 100 milliliters of the 1%. She's trying to figure out how many milliliters of the 4% she's going to add in so that she can end up with 2% solution of the total milliliters, right? 100 milliliters plus X milliliters. So then we just go ahead and we solve that. So we've got the 0.01 times 100, of course, we got the 1 plus 0.04x. We got the 0.02 times 100, so we got 2 plus the 0.02x. Get all your x's on one side, all your variables on another. So we got 0.02x equals 1, and then we divide by that 0.02. So x equals 50 milliliters is how much of the 4% solution. That's how much of the 4% we got to add in. All right, last one. We got this rectangular plate. This will be the base for a circuit board. Its length is 2 inches more than the width. So here's our width, and this length right here is 2 more than that, 2 inches more than. And has a perimeter of 36 inches. So the perimeter, 36 inches. If you remember the perimeter, you're adding up the length plus the length plus the width plus the width. So we got 2 times the length plus 2 times the width is your total perimeter, which here they tell us it's 36 inches. So 2 times the length, well, the length is the 2 inches more than the width. And now we can solve for this width. So we got 36 equals 4W plus 4. We subtract 4 from both sides. 32 equals 4W. Divide by 4, so we got W. The width is 8 inches. So what would the length be? Well, the length is W plus 2. And we know that width is now 8. So 10. So this is a length times width. Here's our dimensions. 10 inches by 8 inches is the length of this circuit board. All right, thanks for watching. We'll see you soon.